A product is a program equivalence checker that checks the equivalence of two programs. Here is an example program in C, which is the strlen function, the simplest possible implementation. And here is a more complicated but much faster implementation of the same strlen function. We can use the equivalence checker to start an equivalence check between the two programs. If you look at the simple implementation, it just looks for the first null character starting at S and then returns the distance. Whereas the optimized implementation first aligns the pointer to 4 byte boundary and then has a bigger loop where in a single iteration of the loop it reads 4 bytes, check if any of those 4 bytes contains a null character, and if not, then jumps by 4 bytes at a time. And so this gives a 3 to 4x speed up over the simple implementation that I showed on the previous slide. Our equivalence checker is able to compute equivalence for the two programs. Equivalence here means that the two programs show identical observable behavior, which means they print the exact same things and they return the same value and leave the memory in the same state. The equivalence proof is a formal mathematical proof of equivalence which shows the lockstep correlation between the two programs and also encodes the values and of the variables and the relations between them when the lockstep happens. For example, if the optimized program goes to the first loop, then this is what happens in the simple program, and so on. Here, for example, one iteration of the optimized loop is equivalent to 4 iterations of the simple loop. Now, although I'm showing this only for two C programs, our equivalence checker can be used to compute equivalence of a C program and an assembly program. On the right is an optimized vectorized assembly program generated by a compiler, and on the left is a simple C program that basically has a for loop and an if then else. Our equivalence checker works for large programs and across many complex transformations. It has many applications. For example, in reverse engineering, where a programmer is reverse engineering the machine code into source code, the equivalence checker can be used to check the equivalence of the two programs. It can be used for checking the correctness of a compilation if the compiler is not trusted. This is especially useful in safety critical settings. And it can be used to check the implementations that have been independently written for the same function by multiple programmers. For example, we have tested multiple functions in multiple C libraries using our equivalence checker. Over the years, we have discovered multiple bugs in compilers and C libraries. Here is an example of a bug report where we share the input on which the C library function gives the wrong output. And there are examples of bug responses where the library authors thank us for the bug. Here is an example of a bug which is a very subtle bug where they're missing out a corner case in the strrchr function where the function returns the wrong value if the character being searched is the null character. And here is a bug reaction where the author of the library says that the library function swap in the netBSD library was incorrectly tested for 2 decades and broken for years, but it was caught by our equivalence checker, which shows the value of a formal mathematical equivalence checker like ours.